Hello, welcome back. So today we'll learn how to use the law of cosines to help us solve non-right triangles. So base our goals then, understand the situations where we can use the law of cosines to do that, understand what can possibly happen, some of the possible outcomes, and then also then be able to use law of cosines to solve the appropriate non-right triangles. So remember, a non-right triangle is just simply a triangle that does not have a right angle. And so they basically have kind of two basic shapes. So you can have one, maybe like this, where all the angles are smaller than 90. So let's call this angle A, B, C. And then their opposite sides, side A is opposite angle A, side B is opposite side angle B, and side C is opposite angle C. Or you can have one angle that's bigger than 90 degrees. So we'll kind of label it the same way. So here's side A, side B, and side C. So these are non-right triangles, basically a triangle that does not have a right angle. Sometimes called an acute triangle. It's called an obtuse triangle. Okay. Now, use called the law of sines. Looks like this. There are basically three rules for each, essentially depending on how you label your angles and sides, then basically these all have basically the same form. So for example, for side A, so side A squared is equal to the sum of the sides of the other two squares, similar to Pythagorean theorem, but it's not the Pythagorean theorem. So be clear with that. Pythagorean theorem is only for right triangles. And then you have minus 2bc times cosine of A. Okay. Actually, if angle A was a right triangle, a right angle, the cosine of A is 0. So actually this then becomes Pythagorean theorem if you have a right triangle. So essentially this kind of collapses to Pythagorean theorem in that case. Okay. And so basically we can set up so these statements are the law of cosines, and basically depending on what we're given, we use these. Now, essentially two cases which we use these. So law of cosines solves a non-right triangle when you know two sides of the triangle and what's called the included angle or the angle in between them. Okay. Let's talk about that. That's called the side angle side case. So we're going to use law of cosines for what's called the side angle side case. And once again, this could be for either kind of triangle, but I'm just going to use this one. Looks like this. Let's say we know this angle and we know two sides and know the angle in between them. Okay, so look at our formula then. For example, this was side A, that's what we know. So the opposite side angle A over here would be sum of the squares of the other two sides, these two sides, and then minus 2 times those two sides again times the cosine of this angle. Okay, so that's one case which use them. It can also be used when we know all three sides. So it's called the side case, as you can imagine. So in that case, then we simply know all three sides, but we don't know any of the angles. Okay. So in that case, what we have to do then is either plug all the sides in and solve for the angle, or just simply solve each formula for the particular angle. You do it either way. Okay. Now, the side case, it is possible to have a triangle, have no triangle at all. Basically, because essentially that means if I simply give you three lengths, you can't necessarily make a triangle with that. It's possible one side might be too long or one side might be too short to actually have a triangle. And so we'll see, let's do an example of that. And basically what happens is you get a situation where the cosine of the angle then is actually not possible. Finally, if a triangle exists, so if you're actually going to picture what's supposed to be an actual triangle, or if you actually have a physical triangle, as long as the triangle actually exists, you can always find the value. You can always solve it, once again, giving these three cases. Okay. And at the end, when we wrap this up, we'll come back and take a look at when to use the law of sines, the law of cosines. So if you've seen my previous video on the law of sines, we'll wrap up talking about how to know which case or which cases to use each one. So let's take a look at some examples. So our direction should be to solve. Let's look at our first one. So let's say we have this. So we have let's say maybe a triangle is kind of this shape. We don't know exactly, but let's say we know this angle 60. This is angle 61 degrees. And two sides. This side is 4. This side is 6. Let's call this angle A, B, and C, like we did above. So this is side A. And so the three things we don't know side A. We also don't know angles C and B. Okay. So this is the side angle side case. Two sides with an angle in between them. And also, this is the case we could not use the law of sines to solve. We can use the law of cosines. So let's take a look. Okay. So once again, we need to find those three things. We need to find side A and then angles B and C. Okay. Now, actually, what we'll have to do first then actually is, if we take a look at our formulas, our laws, we actually need to find A first. Because if we try to find, because either one of the other, to find either one of the two angles, either angles B or C, if you look, for example, trying to find angle B, we need to solve this for the cosine of B. We don't have side A. Each one of those requires side A. So actually, we have to start here is actually find side A. Then we can use the law of sines or law of cosines to find other two angles, one of the other two angles. So let's first off, let's find A. And so we'll just use the first statement, which says A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of angle A. And here, just plug everything in. So plug in our values that we're given. And so that's going to be A squared is equal to B, which we're calling 4, so 4 squared, plus C, which is side C, which is 6 squared, and minus 2 times 4 times 6 times cosine of 61 degrees. Okay, now the best thing to do is probably just put all this into Desmos or into your calculator. Okay, in fact, also probably the best thing to do is, since you just do the square root of all of this. Okay, so 4 squared plus 6 squared minus 2 times 4 times 6 times the cosine of 61 degrees. That's the most straightforward thing. That way the calculator carries all decimal places. Don't have to worry about inaccuracies and rounding off at each step. Okay, let's do that then. So let's go to Desmos. Let's use your calculator. So we go to Desmos, desmos.com. Now, one thing you need to do, since we're doing this, you can either, your angles can be either radians or degrees, but typically going to be in degrees of applications. So let's make sure you're in degree mode. So the default is radian mode. So put it in degree mode. Click on degrees. Now it's in degree mode. So click anywhere outside the box to go back to the screen. Okay. So let's plug all that in. So we said equal to, now do a square root. You can either click the keyboard and hit the square root down here, or just type SQRT, that gives you a square root. Now 4 squared plus 6 squared, okay, minus 2 times 4 times 6 times cosine of 61 degrees. And what's going on here? Oh, I'm sorry, I don't need the equal sign. There we go. Okay. So we do 2 decimal places. That's approximately 5.36. Okay, we didn't give units, but if you want to think of this feet, meters, inches, whatever. So 5.36. Now, it's not wrong to actually find each one of these values individually, then combine them all, then take the square root. But this way, you should have the most accuracy because your calculator is carrying all your, a lot more significant digits than we want to have to fool with. Okay, so that's side A. Now, at this point, then we have options. We either use side C or angle C or angle B, either one. So here, let's just say find B, one alphabetical order. Now, let's use a relationship for B. Let's write it out first. I'll just say use that. So B squared is equal to A squared plus C squared minus 2AC times the cosine of B. Now, you can either do this two ways. you can either solve uh, this formula for the cosine of b or plug everything in first, then solve for b. So actually, I'm just going to solve this for b, for the cosine of b. Okay, so we subtract. So we're going to have b squared minus, oops, not yet, minus. So if I subtract both these terms, minus a squared minus c squared, okay, that's equal to minus 2ac times the cosine of b. Okay, and then divide both sides by this, minus 2ac. And that will give us then a expression for, let's turn it around, the cosine of b, angle b, is equal to sine b squared minus a squared minus c squared all over minus 2ac. Now just plug in the values we have. And so the cosine of b is going to equal to, and so b, see, sine b was 4 squared minus a, and we found a, that was 5.46 squared, minus c squared, and c was 6 squared. This is all over minus 2 times a, which is 5.46 times c, which is 6. Okay. All right, so let's actually just plug all that into Desmos or your calculator as well. Okay. And double check that was 5.4, yes, 5.46 for A. Okay, now here, let's make sure you use parentheses. So it's 4 squared minus 5 point, 5.36, if I can see it above there, 5.36, 6 squared minus 6 squared, okay, then divided by negative 2 times 5.36, which was A, times 6, okay, and that is approximately let's do 5 decimal places, 0.75761. Okay, so that's the cosine of b. We want b itself. So take the inverse cosine of both sides. This becomes, then b is equal to the inverse cosine of this. Let's going to make sure in degree mode, 75761. And let's go back to Desmos. Now do the inverse cosine, click on the keyboard, go to functions, and then you'll find the inverse trig function. Just use inverse cosine, and then point, of course, you can do as many places you want, 0.75761. And that, once again, let's just use 2 decimal places, 40.75 degrees. So B is equal to 2 decimal places, 40.75 degrees. Okay, that's angle B. Then we have one more thing to do. We can find C, and that now is easy because, of course, use the law of cosines again, but now that we have 2 angles of the triangle, we just have to subtract that total from 180 to find C. So C is going to be 180 degrees. Remember, for any triangle, right triangle, any triangle, all the angles still have to add up to 180. So 180 minus 40.75 plus 61, the other 2 angles. And then I'll just do this on my calculator. Don't worry about going to Desmos. And that means that angle C is going to be 72 decimal places, 78.25 degrees. Okay. Now, let's take a look at our triangle again, make sure all numbers make sense. We're not guaranteeing it's correct this way, but this is something to make sure everything is reasonable. So we said before that basically for a triangle, any triangle, the bigger your angle, the bigger its opposite side should be. So our biggest angle is C. So we should have the biggest opposite side, which is 6, and that's true. The other two sides are 4 and 5.46. Okay. The smallest angle was angle B at about 41 degrees almost. And this shows the smallest opposite side, which is 4. That's correct. And A had the middle angle had the middle side. That's correct. Good. Not a guarantee everything is correct, but at least you know our triangle is consistent and the relationships with each other's are right. Okay. Now, that obviously was the side angle side case. So example number 2, and this is going to be the side case. Let's say we have a triangle that looks like this. Okay, or assume it looks like this. And so, of course, here is angle A, angle B, and angle C. And our sides are this side is 4, this side is 8, this side is 10. Okay, so obviously this is the side case. So what we need to find then are obviously our angles. So we know all our sides, so we want to find angles A, B, and C. Now here, it doesn't really matter which one we start with because basically all our angles are unknown. So I'll just start in alphabetical order. Let's find angle A. Okay, so like I did before, let's use this first relationship. A squared is equal to B squared plus C squared minus 2 BC times the cosine of angle A. And once again, I'm going to solve for cosine of A. Okay. And if I do that the same way I did a minute ago, I'll spare you the steps. We subtract both these terms on both sides and then divide everything by this. And so it'd be just like you saw before, the previous one, solving for cosine of angle B. We did that. This is going to be A squared minus B squared minus C squared over negative 2 times B times C. Okay. Now, let's again plug everything in. Plug in what we know. And okay, so side A was 4, that's 4 squared, minus B. So B was 10 and C was 8. So side B is going to be 10 squared minus 8 squared over negative 2 times 10 times 8. Okay, and this should be equal to the cosine of A. Okay, once again, let's go to Desmos and plug all that in. See what number we get. Okay, so I'm going to use parentheses here. And so, I don't remember what it was. So 4 minus 10 minus 8. So I have to remember in my head what that was. So 4 squared minus 10 squared minus 8 squared. And close the parentheses, then divided by minus 2 times 10 times 8. Okay. And as we see, that's actually came out with a few decimal places. So 0.0 or 0.925. That's simple. Okay. And so let's going to take the inverse cosine of both sides. Then it says angle A is going to be the inverse cosine of that value, 0.925. And let's do that with Desmos. That will tell us what angle A is. So we can do inverse cosine, go to the keyboard, the functions, and then inverse trig functions right there. Oops, I put it in the wrong place. Sorry. All right, let's do down here. Now do the same thing. Functions, then inverse functions, inverse trig functions, and inverse cosine, and of 0.925. Okay, and as you can see, that should be approximately to 2 decimal places, 22.33 degrees. All right, that's the first angle, angle A. Now, let's go ahead and find angle B. Okay, so use a relationship for angle B, and once again we can do that because we know sides AC, and we're looking for cosine of B, and we know all three sides. We're going to use this ship for B. B squared is equal to A squared plus C squared minus 2 times A times C times the cosine of B. And like we did in the previous example, we're going to solve for the cosine of B. So if we do that, then we get that the cosine of B, angle B, is equal to B squared minus A squared minus C squared, okay? Then all over minus 2AC. Then once again, plug all the details in. And so we're going to have the cosine of B is equal to, let's going to look back again. So B was 10. It's going to be 10 squared minus 4 squared minus 8 squared over minus 2 times 4 times 8. And we'll check that little notes. So we're going to keep going back. Okay, and once again, let's plug this into Desmos, see what we get. So it's going to use parentheses. So 10 squared minus 4 squared minus 8 squared, and then divided by minus 2 times 4 times 8. And that's negative 0.3125. So negative 0.3125. Okay, so once again, take the inverse cosine of both sides. That means angle B is equal then to the inverse cosine of that. Okay, and let's do that on the next line. So then go to functions, inverse cosine of negative 0.3125. Yeah, and since it's negative, that means we're going to have an angle bigger than 90 degrees. And so angle C, angle B rather, should be 108.21. Just do some places. Yeah, excuse me. So that's our angle B. And then finally to find C, and that's the easiest one because now that we know all three of the other two angles, we just do that angle C is going to be 180 minus the sum of the other two. So minus 108.21 degrees plus angle A, which was 22.33 degrees. Okay, and I'll just use my own calculator to do that. Sorry, I made a mistake, so let me try that again. Okay, and that should be, so angle C should be approximately 49.46 degrees once again to 2 decimal places. Okay, once again, let's kind of make sure it's consistent with everything. So our biggest angle is angle B. Our second largest is C. Our smallest is angle A. So let's make sure all those sides are consistent with that. All right, so the biggest angle is B. That has the biggest opposite side, correct? The second biggest angle is C, has the second biggest opposite side, correct? And the other one, at least the relationships between the angles and their opposite sides are correct. So once again, it's not a guarantee everything works. That's a good indication that at least we're on these everything's consistent. Okay, let's take a look at one more example. What I want to look at here is what happens if we have, three sides that don't actually make a triangle. So let's take a look at this. So let's imagine, let's take the last example and modify it. Okay, so this last example, we had these three sides. So what if this side here, instead of being 4, was only a length of 1? Okay, so let's do that. So what I'm saying is, it looks like this. Let's say I have this side is still 10, this side is still 8, but this side is only 1. Okay, length of 1. Now, how do I know that's actually not a triangle? How do I know it? Well, if you can imagine, make a triangle, then these two sides added together have to be at least as long, or have to be longer than the third side, right? So 8 plus 1 is 9, is not equal to 10. So if you imagine folding these sides in, they wouldn't meet each other. So we know that can't be a triangle. Okay, this is obviously not a triangle, and we can see that. But the thing is, what if someone just gave you, so these three sides, these three numbers, how do well you know that's not a triangle? Okay, well, we'll show you how to find out. Let's do this the same way. So let's say this would treat it the same way. Let's say it was A. If it made an angle, this would be angle B, and then this would be angle C. Let's do the same way. So let's kind of approach it the same as it did before. Find A, B, and C. Okay, as if this is a side case. All right. So let's find A. Okay, I'm going to cut straight to the chase and go and give you the formula for A has been doing. So that's going to be the cosine of A is equal to A squared minus B squared minus C squared over negative 2 BC. And that's as if I took this first one and solved it for the cosine of A. Now, let's again plug in what we have. And if we do that, then cosine of A is equal to, it's going to be 1 squared minus 10 squared minus 8 squared all over negative 2 times 10 times 8. And what we should see, let's actually turn that off for a minute. So go down here, this parentheses. So 1 squared, of course, is going to be 1 minus 10 squared minus 8 squared. Okay, and divided by minus 2 times 10 times 8. Okay, now that's 1.01875. Now, but what happens when we try to do this? So, of course, we probably approach it the same way. A should be the inverse cosine of that. But if you try and do that, let's try and do the inverse cosine of that. Hopefully you notice right away what's going to happen, but let's go ahead and try it anyway. So the inverse cosine, 1.01875, notice it says undefined. That's because that's outside the domain of inverse cosine. Okay, so basically, remember the cosine function, its range is just from -1 to +1, not outside that. So that becomes the domain of the inverse cosine. In this case, the inverse cosine, that's outside the domain of the inverse cosine. Okay, so this is actually not defined. Okay, since the domain of the inverse cosine of x, or whatever variable is just -1 to 1. Okay, since it's outside that domain, outside that range, outside that interval, then it's not possible. So that tells you then this is not a triangle. Okay, so if you saw my previous video on the law of sines, we saw a similar thing when in the ambiguous case of law of sines, that if you get something, you're trying to find the angle, okay, using either law of sines or law of cosines, you get something outside the domain of the inverse trig function, indicates it's not actually a triangle, doesn't actually make a triangle. That's useful then to help us know when something doesn't work. Because like I say, if someone simply gives you some numbers and say these are all the sides of a triangle, or this maybe some combination of sides and angles of a triangle, it isn't necessarily the case. You can't necessarily make a triangle from those things. That just depends on if they all work together. And this is a good thing about this mathematically, is that the math essentially actually helps you to know whether that's possible or not. In this case, it's not a triangle. Okay, now the last thing, let's talk about how to review how to know when to use law of sines or law of cosines. So once you've seen my previous video on law of sines, and we know there, we use it in the case. Let's actually go back to our triangles we started with here. Okay, our non-right triangles. Okay, so the cases we use the law of sines are when you know two angles and any side. Essentially, that's what's called the angle side or angle side angle. So as long as you know two angles and any side, you can always find the third angle because all the angles must add 180. And then in that case, you're guaranteed to have a unique triangle. Only one actually will be a triangle. Okay. Now, the other case, what's called the side angle, we have two sides, one the opposite angle. So for example, let's say we knew side B, side A, and either angle A or B. That's called the side angle case. And that's also called the ambiguous case because you can have one unique triangle. You can actually have two triangles which fit that data. It's also possible to have no triangle. That's why it's called the ambiguous case. And that's when you use the law of sines. Then you use the law of cosines when you have the side angle side case, when you have two sides and the angle in between them, okay, which you can't do the law of sines. And then finally, we know all three sides that we've seen, it also means you cannot do with the law of sines. So that's how to know when to use each relationship. And then make sure you understand then what can happen, the possible outcomes and possible issues you can have using each method. Thank you. Have a good day.